Assalamualaikum and good day everyone. Okay, now we're going to continue our lecture. Okay, so previously we learned about the electromagnetic field with 14 part 1 until the section of lossy media. Okay, the lossy media is treated as the fundamental for us to study further types of medium. Okay, so now we continue with the next medium. Okay, the EMT, the electromagnetic field. Okay, electromagnetic wave in lossless media. Okay, so in the lossless medium, okay, in the lossless media means this is a perfect media, perfect lossless media. Okay, means it's a perfect dielectric. Okay, perfect dielectric meaning to say that the conductivity is zero. Okay, so it really cannot conduct any electricity. Okay, and this is actually in real life. Okay, it's very difficult to have this kind of material, and most of the time it is expensive. Okay, so the loss tangent, okay, the loss tangent for the lossless media is zero. Okay, and also we know that the equation for the loss tangent is sigma over omega epsilon. Okay, so this equals to zero for the lossless media case, and the intrinsic impedance, okay, sorry for that, the intrinsic impedance is square root j omega mu over j omega epsilon. Okay, and we okay, and because it's and you see the angle is 0 degree. Okay, for this lossless media, and then the square root is further simplified, equals to square root of mu over epsilon. Okay, this is why does this happen, because your sigma here is 0. Okay, so like what I told you guys in the previous lecture, okay, the lossy media will be treated as fundamental. So this is where we further simplify the equation, okay, accordingly. Okay, in this case with regards to lossless media where sigma is equals to 0, so this one equals to 0. Okay, then you only have j omega mu and j omega epsilon, so this one you can cancel out, then you have mu over epsilon. Okay, and the angle is 0 degree. Okay, next for the alpha and beta, okay, because mu sorry, for the alpha and beta, the alpha is equals to 0 in the lossless media, and the beta is equals to omega square root of mu epsilon. Okay, and then where x is equals to sigma over 2 epsilon. Okay, here is the where you do the insertion. Okay, insertion of sigma 0, then you have this equals to 0. Okay, so you left with only 1. Okay, so this one here 1, and this one here is 1. Okay, and 1 plus 1, okay, is 2, and 2 will be cancelled out with this. Okay, the same goes to here, we cancel out with this. Okay, sorry, this one is cancelled out, is 2, 1 plus 1 is 2, so this one didn't. Okay, this one is 1 minus 1. Okay, 1 minus 1, which is 0. Okay, which is 0. So everything times with 0 will become 0. That's why this alpha is 0. For the case of beta, 1 plus 1, 2. So you can cancel out. That's why you only left with omega square root of mu epsilon. Okay, so you have here. Okay, remember the unit. Alpha is Nepal per meter and beta is radian per meter. Okay, in this lossless media, okay, we continue. Okay, so if we have these equations, okay, in the lossy media, we notice that one of these two equations will have the angle of the intrinsic impedance, right? Before, in the lossy media, we have this angle, either here or here. In lossy media, is the E leads the H, or H lags the E. Okay. In the lossless media, however, the E, you can see here, E and H, they are in phase. Okay. So you can see they are the same. Okay. They are the same phase at particular location within the Z propagating directions. Okay, so you can differentiate this compared with the lossy media. Okay, and of course this is also valid for this loss media. For this equation, the interrelation between the H naught, E naught, and the intrinsic impedance. Okay, you guys see, they are all this equation showing that they are in phase, and this showing that it is moving in the positive Z direction. Okay, so in a lossless media, okay, so we go to the next, we go to the example. In the lossless medium, it's mentioned here. Okay, the intrinsic impedance is equals to 60 pi, and mu r is equals to 1. H is equals to negative 0.1 cos omega t minus z in of x components. Okay, find the E. Okay, so they are the answer, they are in phase. Okay, you just need to you see, you do the substitution E naught cos omega t minus z, they are the same. Okay, they are just in phase, but few modification just need to be done. Okay, and E naught equals to intrinsic magnitude of intrinsic impedance times H naught. Okay, where you have this H naught is negative 6, 0.1 time with this 60 ohm, 60 pi, then you have this. Okay, and then you can see this is your H in the directions of X. Okay, and in order to have your E, it is a cross between the direction of the magnetic field with the propagation of the wave. Okay, so X with regard to your H field, and then Z with regard to the direction of propagation. So you have the E is actually in the negative Y unit vector. Okay, so completing the substituting all the values, you have the equation for electric field is equals to 6 pi cos omega t minus z and y direction, and because this is electric field, it is vector per meter. Okay, next we go to the next types of medium, which is the free space. Okay, so this free space you can regard like as in the vacuum, in the air. Okay, but air depends. Okay, depends. Okay, in because in if you have different gases, you will have different uh, carry different materials. Okay, but this one just assume free space, just like a ideal free space. Okay, so in free space, the sigma, okay, the conductivity is equals 0, mu naught epsilon naught. Okay, this value you can find in the calculator. Okay, or you can see from the book. Okay, this one is a known value mu naught epsilon naught, because every time when we showing this is actually referring to free space. Okay, and the loss tangent. Okay, loss tangent sigma over omega epsilon, because your sigma is 0. Okay, so it is 0 here. Okay, so your loss tangent in free space is 0. So this is the alpha, beta, and the velocity. Okay, in free space, the alpha is equals to 0, the beta is equals to omega square root of mu naught epsilon naught. Okay, and u, the velocity, is equals to omega over beta equals to c. Okay, c is the speed of light. Okay, your c. Okay, so magnitude of intrinsic impedance is equals to square root of mu naught over epsilon naught, and is equal to 377 ohm. This is a fixed value. Okay, because this is fixed value, so in free space, your magnitude of intrinsic impedance is always 377 ohm, and the angle of intrinsic impedance is the angle, okay, is 0 degree. Okay, in free space, okay, they are in phase again. Okay, just like in the lossless media, your E and your H, they are in phase. Okay, meaning to say in the Z propagation of wave, you can see they are achieving at the same phase. Okay, location, the same phase at particular location. Okay, for location 0, for example, here they are at the same phase for both E and H. And just like we know, in free space, the magnitude of intrinsic impedance is fixed, which is 377. So that's why you can just substitute this value. Then in free space, this kind of like H naught equals to E naught over 377. Okay, because in free space we have readily value of intrinsic impedance 377. Okay, next we go to the next medium, which is the conductor. Okay, so in the conductor, the sigma, okay, the sigma is where it is the conductivity. Okay, it have no limit. Okay, practically like it can be high value, because the better the higher the value of sigma, means the better the conductivity. Okay, so that's why you can imagine here like an infinity. Then you have mu naught epsilon naught, and then the loss tangent, because this sigma can be high of value. Okay, from here, that's why your loss tangent can be more than 1. Okay, far greater than 1. Okay, for alpha is in conductor, alpha is equals to beta. Okay, and then they are equals to mu times omega sigma over 2 square root. Okay, which is the units of Nepper per meter. Okay, the skin depth is equals to 1 over alpha. Okay, and the magnitude of intrinsic impedance is equals to square root of omega mu over epsilon. Okay, tangent to theta n is equals to the same way as in the other equation. Okay, in the other medium, tangent to theta is equals to sigma over omega epsilon. So because this one is high, so it can be more near more or less infinity. Okay, so 2 theta n is equals to 90 degree and theta n is 45. I think this one you guys can relate with the equation of with the when we try to plot the tangent. Okay, the angle. Okay, when you do the plotting, okay, the plotting with theta and theta and theta, okay, then you will see there's a like a exponential. Okay, in the conductor, okay, the E and the H, okay, you see here there is a difference now, okay, in the conductor due to our previously found value, which is 45 degree. Okay, so that's why you have 45 here, and see you, this is your H and this is your E. Okay, so there is a difference now. The difference between them, okay, is 45 degree. Okay, the phase. Okay, the distance where wave has decreased 37% of its original value. Okay, so the skin depth is 1 over alpha, and alpha is equals to this value. Okay, so this is the skin depth. Okay, this is your skin depth. Okay, and as you standard, H naught equals to E naught over intrinsic magnitude of intrinsic impedance. Okay, so example 4, a uniform propagating wave in a medium has E field equals to 2E negative alpha x sine 10 to the power of 8 t minus beta z y v over meter. If the medium has dielectric constant equals to 1, okay, the relative dielectric constant equals to 1, mu r equals to 20, and sigma equals to 3 milli 3, okay, per meter. Find alpha, beta, and magnetic field. Okay, because given E, now they want to find the M ultimately at the end. Okay, this kind like a guided question because they will ask you to find alpha and beta first. Okay, so alpha, so you have alpha equals to 61.4 Nepal per meter and beta 61.4 per meter. You just insert the value, okay, from the equation that we discussed just now. Then you have substitute with for the H field, and you have this angle. Okay, this is theta n, which is 45 degree. Okay, this one is described in radians. Okay, because alpha over 4, pi over 4 is equals to 45 degree. Okay, radian. I think you guys know, right, how to convert between radian to degree scale. Okay, so E is actually 2E to exponent negative alpha x sine 10 8 t minus beta z y v over m. Okay, answer: to determine medium, we find loss tangent. Okay, loss tangent, we know that it's actually sigma over omega epsilon. Okay, and this is the inserted value. Okay, and 10 8, this one we just insert accordingly. Then you will see that your loss tangent, okay, is much greater than 1, which is 3388. Okay, this is common for conductor. Okay, general equation of magnetic field that we found, then H is equal to this value and the theta n. Okay, so insert accordingly for this magnitude of intrinsic impedance is tangent to theta n, because you already know is okay, it's equals to 3881. Okay, 3881. Okay, so 2 theta n equals to tangent, inverse tangent of 3881. You have is almost like to 90 degree. Then you get theta n equals to 45, just like we know in conductor, right? So alpha equals to beta in the conductor medium. So you have it is 61.4. This one is you just insert the value, okay? And then h equals to negative 69e, negative 61.4 x sine. Then you have this theta in here, okay? So x direction, and to determine the direction of the h, okay, is actually just like the cross between E and the direction of wave propagation. This is just the same. If you have E here, then it is a curl of H with is a cross between H and the direction of propagation. So this is your x direction and negative. Okay. So this is the summarization, okay, of the whole things that the electromagnetic wave in the medium, okay, in lossy medium, lossless medium, conductor medium, and in free space. Okay, this one lossy medium is treated as the fundamental case. Okay, because we will further develop our value for sigma, alpha, beta, and so on from the case of lossy medium. So make sure you guys understand first the lossy medium, okay, properly. Then you will move forward to learn further to the another three types of medium. Okay. Next, we go to the next lecture is the pointing theorem. Pointing theorem is the total power out of a volume is equals to rate of decreasing electric and magnetic energy plus the ohmic power. Okay, if you want to find this, the proof is in the textbook. The study book will tell you in detail. Okay, how to get how to prove this. Okay, so the closed surface integral of E cross H dot ds surface differential is equals to the d over dt integration of half epsilon E square plus half mu H square dv, okay, because it's a volume integral, and minus volume integral of epsilon E square dv. Okay, so pointing vector, okay, is equals to E cross H, okay, which is the, and then the unit is watt per meter square, and then for the average power is equals to 1 over T integration of 0 T, okay, because time from 0 you cannot have negative 1, right? So 0 to T, and you have dt, okay, and the average power you find is actually the curl, the cross between E cross H, then is E naught over E naught. Okay, how you obtain this E naught? you know, right, the interaction that between the H naught, E naught, and intrinsic impedance that we discussed in the previous 4 medium. Okay, that's why you can see it like a double here. Okay, E exponent negative alpha z cos theta n, average power through any surface S. Okay, surface S is the P average equals to integration of S surface integral, okay, dot with your average power that you obtain from here. Okay, we move to the example 5. Okay, in a non-magnetic medium, find relative dielectric constant, or this one also can be called as dielectric relative permittivity, intrinsic impedance, and power average, and total power crossing 100 centimeters square. Okay, please remember this unit 100 centimeters square, because sometimes if the question using different units and you didn't standardize them up, or you don't aware, then you make wrong calculation. Okay, because you know sometimes it's mentioned as centimeter, sometimes as meter, sometimes as kilometer, for example. Okay, so you need to always alert of this. Okay, in a non-magnetic medium, find the relative permittivity and intrinsic impedance, power average, and total power crossing 100 centimeters square. So this is your surface. Okay, on a plane 2x plus y equals to 5. Given the propagating wave is E equals to 4 sine 2 pi times 10 to the power 70 minus 0.x x. Okay, so this is the answer. Okay, I think you can just do from the formula that you see from the previous slide. Okay, and do it properly, then you will get it. Okay, so once you manage to do your own, then you can check up with your answer here, are they the same or not. Okay, so the answer is given with the working step here, the same here as well, and here also is. So you are given. Okay, so try to do the example. Okay, for this pointing vector at the end. Okay, since the answer is given. Okay, with that we finish our lecture. So we will proceed with the next lecture, which is the last lecture, inshallah. Okay, for this course. Okay, Assalamualaikum and good day.